Hi, in this video we're going to talk about the output compare operation of a timer and especially of the timer TIM4, which is appropriate for this purpose. So let me tell you some words about what is output compare. Output compare is the scheduling of an event on a specific output pin after a number of pulses. So, for example, you can define that on a specific pin that is related to channel, let's say 3 of a timer counter, we will set the output pin to be toggled after 1000 pulses. So in this way, during the initialization phase of a timer, we define what we do like to happen on specific output pins after a period of time. There are multiple output pins that can be used, and there are multiple output channels that can be related, each channel to each pin. So this means that we can schedule different things to happen on different output pins. So let's start our project. You can see the STM32CubeMX tool that will be used for convenience. The first thing we do is to start a new project. As we did in our previous video, we have to find the board and the microcontroller that is used. It is STM F407. 407. There are multiple alternatives for 407, and this is the most appropriate, the 407 VGT6. So I select this one and I start the project. Now, we will use the 4 pins that are connected to LEDs on this specific development board that we use in this laboratory. So I will find the PD12, 13, 14, and 15, and will assign them to channel TIM4 channel 1. This is the reason why I will base my project to TIM4, because this channel exists only with TIM4. This one, I select the pin TIM4 channel 2, the PD14 to TIM channel 3, and the PD15 to TIM channel 4. Okay. Now, from the timers, I select timer 4. And for this timer, as I did in my previous exercise, I select internal clock. I have to tell you right now that the internal clock I select is a 16 megahertz clock. And this matters relating to the related to the configuration that we will do next. Here are the 4 channels that I just asked the pins PD12 up to PD15 to be assigned to channel 1 and channel 4. And from these options here, I can select what kind of operation I would like to happen on this channel. So as I said earlier, this is an output compare operation. So output compare on channel 1. Concerning the parameter settings, okay, let's first assign all the rest of the channels. This is output compare on channel 2, this is output compare on channel 3, and output compare channel 4. Let me see my notes also to make sure that there's no mistake in these operations. Okay, change of them, and okay. So let's go to the configuration and the pulse field beneath. First of all, with the parameter settings, I have a prescaler here that is 0 initially. What did I said earlier? I said that the internal clock is a 16 megahertz clock. If I select 16,000 to be my prescaler, this means that the counter will change by 1, will be increased by 1 every 16,000 pulses. But this means, since my clock is 16 megahertz, that each pulse will occur every 1 millisecond. Okay, this is what I did using the prescaler setting. Now, the upper value of this counter, the last value it will count before overflow, is now 65535, which means 64K. This corresponds to a 16-bit resolution, but I will reduce it to 1000. This means that when the counter reaches the value 1000, it will overflow and will return to 0. Okay. Now, concerning the output compare operation that I selected, I will change the pulse value to the number of value to the timer value where I would like to change this output compare. Let's see what we should select at this point. The mode of the operator, as you'll see in my notes, has to be toggle on match. This means that whatever was the timer before, if it was whatever the pin was before, if it was set to 1, so the LED was leading, was on, when the value of pulse is reached by the counter, then this LED will turn off. If it was off, it will turn on. This is what toggle does. And nothing else, I think, has to be changed here. So let me do these modifications. The mode, change the mode is to toggle on match when the timer reaches the value 500. Output compare is enabled. Do I have enabled here? No, it is disabled, so it should not. I leave it disabled, at least initially. At the second channel, which drives the PD12, again toggle on match when the counter reaches value 1000, or we could do this. Okay, 1000, it's okay. Output compare 3, toggle when okay, the second, the third toggle at 1500, and the fourth channel toggle. Let's see what other options we had. We can force active or inactive the channel, or active level on match, or inactive level on match. Forced active is always 1, forced inactive is always 0. Active level on match is to set it 1 after matching the values of the output compare with the timer counter. So all these options, these are all options. So the last one, let's say that we like to be toggled when we reach the value 2000. Okay, I think we have finished with these settings, and now we do things concerning to the clock configuration and the project manager, which is actually has to be in the project location that I used in the last video under new lab, and the name that I will use is output OC test. Let's call it this way. but I don't forget to change this to MDK ARM. Okay. Now, I think I can generate the project. It will take a while, but since in the same directory I've also installed um, another project in our previous video, it does not take that long, so it's already finished. I can open the folder in order to start the Kale Microvision project. Okay, let's move manually to this place here. Here's my directory, microcontrollers, new lab. Okay. OC test. This one is here, and MDK ARM is where my project is. So I end up the CubeMX in order to start only the Microvision tool. Okay. Maybe I have to do some corrections, like for example, enable the startup option from here, but let's try to build the project initially and see if we get any error. All the messages are shown under in the console at the bottom. Wait for a while. Okay, I see that I have the same error as I did in my previous video, which means that I have to go to the manage runtime environment. And what is missing from the project that the CubeMX created was that with the start device, it didn't add the startup header files. So when I select them, some header files are created, but as I did in my previous project, we see that this STM32F4X6.c is twice created, so I have to remove it once. I remove it from here, remove file from the project. Okay, and now I guess that if I build the target again, it will be completed without any errors. No errors. So I'm ready to connect my board. In order to connect my board, remember that I don't use, since my project was created from the CubeMX, I do not change anything here at the compiler settings, but I have to select the ST-Link debugger. Here it is. And I have to connect my board to the USB port. Okay, it has started, but now I have to verify from the settings that the board is connected. Since I get a known target, something I have to change, and remember that what I have to change is the port, is not JTAG, is a software, and now it is found. So I can press OK, everything's finished, and I have to download the project from Flash download, or from this icon here directly. I get the messages for programming. And now, when I start debugging and run this program, we will see that the LEDs, the 4 LEDs, will be set in different timestamps, in different times. Since for the one I selected to be toggled at when counter reaches value 500, the other to be changed when it reaches value 1000, the next when it reaches value 1500, and the last one when the counter reaches the value 2000. Let's start to see what happens. I press run. And the LEDs don't lit. Let me see where it has stopped. It is within the while. So something is missing probably. Let me see within the MX time init initialization what happens. Probably something is missing from the initialization. Let's go there. It probably does not have the specific command that starts the both the HAL timer and the output compare operation. So let me see my notes. Yes, as you will see from my notes, I have to add these comparisons under the initialization MX time 4. So I will copy paste these ones. It's not in the initialization, but it could be, I guess, in the initialization. I just place them here as I did in my notes. Let's compile again. Of course, first of all, I have to stop the debug session. Let's build the project again. These commands start the timer with the output compare operation. Flash download. Okay, and start the project again. Start the debug session, I mean. Okay. Now, you saw the 2 of the 4 LEDs that are turned on and off at different times, but we do not have anything happening on the other 2 LEDs. So what's happening here? Let me stop the debug session. Let's see again in the code. And let's see the initialization of team 4, where the output compare is probably defined. Here I am within the MX time 4 init. You can see, for example, that the prescaler is at the 16,000 that I selected. The period of the counter is 1000. So let's think about it. We defined that the first LED should be toggled at number 500. Or this is about the half of the values of the timer we set. The other one to be toggled at 1000. This is the last value reached by the timer before it overflows. But what happens with the rest of the 2 pins that were set to toggle at 1500 and at 2000? These values are never reached by this timer. So this is the reason why we do not have anything happening on the other 2 LEDs, and only 2 LEDs can be seen here to be turning on and off. We have 2 modifications that we can do in order to see all the 4 LEDs. We either can change this period to 2000 so that it contains all the timestamps set for the output compare before, or we can change individually, one by one, the settings for each one of the counters. If I keep 1000 the period and go to each one of the channel 1, 2, 3, and 4, here are the settings for each one of these channels. We see that at the first channel it was set to 500 correctly, but let me change it to a value that will allow all the LEDs to be toggled within the 1000 pulses that will be run by the timer. So I will change this to 250, the second one to the 500, the third one to the 750, and the last one to 1000. I scheduled in these timestamps to change the values of the LEDs. So save, build the project. It's quite fast right now. Flash, download to the flash. And okay, I can start now the debug session. And now let's see what happens if I start running. You can see all the 4 LEDs turning on and off in turn, as was scheduled whenever the timer reaches the value 250, 500, 750, and 1000. That's all for now. Thanks for watching.